Hello and welcome to Talking Point. I'm Rowan Ogel, the Deputy Strategic Lead of the National Addiction and Mental Health Surveillance Unit, NAMSU, at Turning Point, and I'll be today's moderator. I wish to start by acknowledging the people of the Kulin Nations, on whose land Turning Point is based, and pay my respects to their elders past, present, and emerging. Recognising that we have attendees based elsewhere today, I'd also like to pay my respects to the traditional owners of the land from where you're based. It's my pleasure to introduce today's speakers, and for something different for Talking Point, we have two. So Lara Piccoli is a second-year PhD candidate in the clinical neuropsychology stream at Brain Park, Monash University. Her research involves using virtual reality and gamified cognitive tasks to understand the cognitive affective mechanisms of alcohol use disorders. Prior to commencing her candidacy, she completed her honours degree at Turning Point in 2020, where she investigated whether alcohol craving mediates the effect of cognitive training on alcohol abstinence. Lara's career goals include continuing her involvement in addiction research whilst working as a clinical neuropsychologist in the alcohol and other drug sector. Also joining us today is Erin Christensen, a PhD candidate based at Monash University's Brain Park and the Turner Institute. After completing her Bachelor of Psychology honours degree at Monash, Erin has worked on multiple projects involving food choice, cannabis use, sleep, and lifestyle interventions. Her PhD project is centred around the neurocognitive predictors of addictive behaviours, ranging from drug and alcohol use to gambling, internet use, and eating. Her work aims to model phenotypes of addiction, teasing apart the neurocognitive constructs that predispose and exacerbate addictive behaviours. If you have a question for either Erin or Lara today, please use the Q&A function at the bottom of your screen, and also make a note of who the question is directed towards. At the end of the session, we'll endeavour to get through as many of these questions as possible. Also, some general housekeeping notes. The PowerPoint slides will be distributed to all of you who signed up after the session, and the video recording will be available to view on the Turning Point website in about a week's time. Over to you, Erin.
So today I'm going to talk about one of the projects in my PhD, looking at the neurocognitive predictors of addiction. It's well recognised that neurocognition plays an important role in addiction. Neurocognitive impairment is thought to be a key driver of individual differences that affect many aspects of addiction treatment, particularly for substance use addiction. The acute and long-term effects of substance use has been found to modulate key neurocognitive processes impacting one's decision-making. This has also been evidenced in non-substance behavioural addictions such as gambling. Addiction is typically associated with a distinct pattern of neurocognitive dysfunction, with a general consensus that it's typified by impaired top-down executive control and atypical risk-reward processes towards the addictive behaviour. It's generally agreed that alterations in these neurocognitive processes are not only implicated during the presentation of addiction, but may also be key mechanisms that provide or that predict the onset or development of addiction, and at the very least will impact treatment-related outcomes. However, in terms of predicting addiction and addiction-related outcomes, a lot of what we know about neurocognition is not based on systematic evidence. Most of what we know is drawn from animal literature or cross-sectional investigations. Today, I'm going to present to you a review of the literature that assesses neurocognition's ability to predict addiction and addiction-related outcomes longitudinally. And the key take-home messages I want you to get out of this talk is that the evidence is really lacking, but this provides a beautiful opportunity for conducting good quality longitudinal research in the future. So I decided to conduct a systematic review to identify the literature looking at the predictive ability of neurocognition longitudinally. I wanted to get a good grasp on the current evidence for key neurocognitive constructs, assessed using standardized evidence-based assessments that we know tap into those constructs, and whether there is a clear link between them and addictive or addiction outcomes. The first barrier to this type of systematic investigation is the heterogeneity in the language used to describe the neurocognitive constructs that are associated with addiction. The term neurocognition also covers an enormous number of domains. I needed to apply some form of framework that would help homogenize the language and also focus in on the key processes that are thought to be involved in addiction. So I decided to use the RDoC, or Research Domain Criteria Framework, which is a framework for investigating mental disorders in which the RDoC have created a matrix. I've put a little screenshot up there for you to see an example that lists domains that represent basic dimensions of functioning informed by genetics, physiology, behaviour, and neural systems that span the full range of human behaviour from normal to abnormal. A group of experts in addiction came together and reviewed the RDoC matrix and came to a consensus on the key domains associated with addiction. So it was these domains that I decided to use to form my neurocognition-related search terms. The literature search focused on only human studies written in English within the past 20 years, and search terms were selected to include key neurocognitive constructs, like I showed on the previous slide, as well as outcomes of interest and key behavioural domains. So there's some examples of the search terms I used up there. Studies included had to be longitudinal, directly looking at how neurocognition predicted future addiction-related outcomes. Neurocognition had to be assessed via methods that produced a behavioural output. So I didn't include studies that used fMRI activation during a neurocognitive task as a predictive variable, for example. Studies had to either not have the outcome of interest present at baseline or control or adjust for it in analyses. For example, cohort studies that looked at alcohol consumption needed to either assess neurocognition prior to exposure of alcohol use or account for baseline levels of alcohol consumption in their analysis model. The literature search revealed over 2,000 studies that underwent title and abstract screening, leaving just under 150 of which underwent full text screening by myself and another rater, and 34 studies were then included in the final review. So what did we find? Of the 34 studies included, 27 unique tasks were used to assess neurocognition. So this shows the real breadth and diversity in the literature. These tasks tapped into 5 key neurocognitive domains, which I'll describe each in the next slide. And these domains sat neatly into 2 categories, those that tapped into cognitive control and those that were associated with positive valence and reward-related processes. So I'm just going to briefly describe each of these domains. In terms of cognitive control, we had response inhibition and selection. So response inhibition refers to the process in which automatic responses are withheld to service goal-directed behaviour. And it's commonly assessed by tasks like the stop signal task or the go, no go task. We also had shifting, which can be defined as the ability to update an established behaviour or thought pattern in accordance with changing circumstances. So shifting is often assessed through set shifting tasks. In terms of our positive valence domains, reward valuation involves the process in assigning reinforcement valence, magnitude, and predictability to a reward and evaluating that in the context of the time delay until receiving the reward and the effort required to obtain the reward. Temporal discounting, or the process of evaluating reward in the context of a time delay, is the construct that was most commonly assessed in the literature we found, assessed via the delay discounting task. Some studies also looked at the probabilistic discounting, which taps into how a value is assigned according to the predictability of a reward. Reward learning is a type of reinforcement learning in which we acquire information from positive stimuli and our behaviour is changed when a novel reward occurs or a positive outcome. For reward learning, I decided to include tasks that either assess reward learning directly, like the two-stage task or the spatial orienting task, or incorporated aspects of reward learning, like the Iowa gambling task. And finally, we have risky decision-making. These are tasks that require the individual to make decisions in the context of explicit uncertainty. So choices are made knowing the likelihood of an outcome is chance. Now we've got our predictors of interest. Let's look at the outcomes that came out in the literature. So the literature is separated into two distinct groups of outcomes: consumption or related problems. So cohort studies that looked at predicting substance use or non-substance related addictive behaviours over time, and treatment-related outcomes. So they were studies that focused on samples who were engaging in treatment and assessed the relationship between neurocognition at baseline and treatment outcomes such as relapse. Just so you know, I will be presenting the cannabis use literature separately at the end, and I'll explain why I chose to do that at that point too. So in terms of consumption and related problems, for our cognitive control domain, all of the studies that investigated response inhibition or selection looked at prediction of alcohol-related outcomes. 6 studies looked at adolescent or young adult samples and found that there was no evidence for response selection or inhibition in predicting alcohol consumption. One of the studies investigated an older, heavy drinking cohort of individuals, and this study found that poor response inhibition was associated with greater alcohol consumption 4 years later, as well as fewer months until meeting criteria for alcohol dependence. So looking at this, you could say it seems response inhibition is not relevant in predicting the early stages of alcohol consumption, but can predict the transition from heavy drinking to dependence. However, Rubio and colleagues didn't control for lifetime alcohol use in their analyses. And we know that alcohol consumption is associated with reduced inhibitory control. So unfortunately, we're unable to know whether their findings truly reflect the predictive ability of response inhibition or whether it's poor response inhibition as a result of heavy lifetime alcohol consumption that drove this effect. In terms of cognitive shifting, we only found 2 studies that looked at shifting, and both of them looked at alcohol as a primary outcome. One study was looking at adolescents and the other at regular drinking healthy university students. Neither showed that shifting predicted alcohol consumption, abuse, or dependence. So at this stage, unfortunately, there's not really any convincing evidence in the literature for cognitive control as a key predictor of alcohol consumption or problems. What about valence reward-related processes? We identified 11 studies that assessed reward valuation in predicting addictive behaviour progression, most of which looked at delayed discounting. All 4 studies assessing alcohol consumption did not find delayed discounting predicted use. When looking at alcohol use problems, however, this is where it gets a little bit more muddy. One of the 3 studies showed a weak association between steeper delayed discounting and higher alcohol use disorder score at 8-year follow-up, whereas the other 2 studies didn't find a relationship between delayed discounting and alcohol use problems. But this is because both of those studies not only looked at delayed discounting as a predictor, but also looked at other neurocognitive predictors in their models, such as working memory and risky decision-making, both of which actually outperformed delayed discounting in their respective models. So it seems delayed discounting may be weakly associated with future problematic alcohol use, but when accounting for other neurocognitive functions, such as working memory, discounting is no longer particularly relevant. Interestingly, when looking at prediction of alcohol and tobacco separately, one study found steeper discounting was only significantly correlated with tobacco dependence at follow-up. A second study also found steeper discounting was associated with increased tobacco smoking over a 5-year period. So this suggests there may be different mechanisms that predict different substances, particularly when comparing alcohol and tobacco. Finally, one study looked at probabilistic discounting and prediction of addiction severity for both substance and behavioural addictions. And they found lower probability for discounting losses was best at predicting increased addiction criteria for behavioural addictions. whereas higher risk seeking for gains predicted increased addiction severity at follow-up for both substance and behavioural addictions. In terms of reward learning, the literature search identified 4 studies that assess reward learning in predicting alcohol and other substance use. And each of these studies investigated very different aspects of reward learning. So I wanted to report them separately and go into a little bit more detail. Chen and colleagues examined how model-based versus model-free decision makers predicted, or decision-making styles predicted drinking trajectories. They used a task that assessed how an individual learns the reward contingencies of the game and is able to adapt their behaviour as the likelihood for reward changes. So if you're a model-based or more model-based in your approach, you can easily adapt your strategy as the task changes, but people who are more model-free decision makers are unable to form clear adaptive strategies. The authors found that model-free decision makers were more likely to consume more alcohol per drinking session. We also found 2 studies that looked at the Iowa gambling task in predicting alcohol consumption and problems. The Iowa gambling task is a decision-making task, but it has an element of reward learning. The individual must learn through trial and error which choices result in the best outcome, so the most points earned across the task. All of these studies showed that poorer performance on the Iowa gambling task predicted heavier drinking and increased problem alcohol use behaviour at follow-up. Finally, we also identified one study from the literature that evaluated reward bias using the spatial orienting task to predict adolescent substance use. And without going into too much detail about the task, essentially the spatial orienting task measures reward bias or bias towards rewards. The authors found that attentional engagement towards reward significantly correlated with prospective substance use. However, when controlling for age, gender, and baseline substance use, reward-related attentional bias no longer predicted future substance use. So this highlights that it's really important to include key covariates in your models when you're assessing the predictors of addiction. So that brings us to our final category of neurocognition, which is risky decision-making. The literature search identified 3 studies that looked at risky decision-making, all of which used the Cambridge Gambles task, and all of which found risky decision-making predicted alcohol use problems at 1 and 2 year follow-ups. So in sum, unfortunately, at this stage, there's not really any convincing evidence in the literature for cognitive control as a key predictor for alcohol consumption or problems. But I have to flag that there was no literature identified in other substance or behavioural addiction spaces. In terms of positive valence, there was evidence that reward valuation measured by the delay discounting task predicts tobacco consumption and dependence, but not alcohol consumption. And probability discounting for losses and gains are predictive of substance and behavioural addictive disorders, but that was based on just one study. For reward learning, there is evidence that some aspects of reward learning is predictive of alcohol consumption and substance use. And there's evidence that risky decision-making predicts problematic alcohol use. So if I wanted to predict future substance-related addictive behaviours, particularly in these adolescent or young adult cohorts, which is quite commonly assessed by the literature we identified, I'd probably focus on reward learning and assessment of risky decision-making processes. So what about treatment-related outcomes? The literature search revealed 4 studies that assessed response inhibition as a predictor for treatment-related outcomes. And these studies looked at relapse, treatment retention, and clinical change. In terms of relapse, only one study found that poorer stop signal reaction time was associated with higher likelihood of relapse in pathological gamblers. And this was not found for tobacco use cohort or a general substance use disorder cohort. None of the studies found response inhibition predicted treatment retention for tobacco, cocaine, and general substance use disorders. While we did have one study by Vergara-Moraguez showing that go-no-go performance predicted likelihood of clinical change, unfortunately, the authors didn't adjust or control for key covariates. So they failed to account for gender, age, or previous substance use history. So we really have to take this finding with a grain of salt. In terms of cognitive shifting, of these 3 studies that were identified, only one showed a significant effect. And that was, again, for Garamaraguez, the same study I described earlier. So we do have to be careful with how much value we place on their results. So overall, there really isn't a substantial amount of evidence showing shifting predicts treatment, retention, or relapse, but a lot more work needs to be done. It's a bit ridiculous that we only found 3 studies. In terms of reward valuation, we found that 4 studies showed that there was no evidence for delayed discounting predicting treatment outcomes for alcohol use, tobacco use, or general substance use disorder. One study did show that probabilistic discounting for losses, but not gains, predicted time to relapse for alcohol-dependent individuals. So lower risk seeking for losses predicted relapse to heavy drinking within 1 year. In terms of reward learning, using a task designed to tap into attention to reward-related cues, Albertella and colleagues found that greater baseline reward-related attentional bias was associated with an inability to remain abstinent during a community-run alcohol abstinence challenge. The rest of the literature we identified looked at the Iowa gambling task. One of the studies showed that poorer performance in IGT predicted tobacco relapse, but this was not found in a cohort of treatment-seeking pathological gamblers. Only 4 studies that looked at the Iowa gambling task, only one of the 4 studies that looked at the Iowa gambling task and treatment retention found a significant relationship between poorer performance on that task and treatment dropout. But I have to note, they had a very conservative sample size and acknowledged that they didn't compare or correct for multiple comparisons. And if they had done so, they wouldn't have found these results. So in sum, there's no convincing evidence that response inhibition or selection predicts relapse or retention for substance users seeking treatment. And that was found for cocaine, tobacco, and general substance use disorder. But there is some evidence that response inhibition can predict gambling relapse. As of yet, we've got no convincing evidence for shifting in predicting treatment outcomes in cocaine use disorder, but there were very few studies done in this space. In terms of positive valence, for reward valuation, there was no real evidence that delayed discounting predicts treatment-related outcomes for alcohol, substance use disorder, or tobacco. But there is evidence that probabilistic discounting, particularly for losses, predicts relapse for alcohol-dependent individuals. In terms of reward learning, we have evidence that reward learning predicts alcohol abstinence ability and tobacco relapse, but there's no convincing evidence that reward learning predicts treatment retention for cocaine, tobacco, or general substance use disorder. Now, before I wrap up, I wanted to present the cannabis use literature separately because it really did stand out compared to the other substances. So the 5 studies that we found looking at neurocognition in predicting cannabis use outcomes using tasks like the Iowa gambling task, the Stroop, the delay discounting task, none of them found that these measures predicted cannabis use problems, disorder onset, or treatment-related outcomes. So we can kind of see a bit of a story around substance-specific neurocognitive predictors emerging from the literature. As I discussed earlier, tobacco seems to have quite different neurocognitive predictors compared to those found for alcohol use. And it seems here that cannabis might be quite distinct as well. So what this tells me is that we really need a lot more research looking at how these neurocognitive domains predict different substance addictions to try and tease apart whether there are indeed substance-specific neurocognitive risk factors. The process of this review revealed some substantial shortcomings in the literature. There was a lack of diversity of substances and very little investigation into behavioural addictions assessed in the literature. Most of the work was done in alcohol use cohorts. There were some clear methodological concerns as well. Most notably, studies did not control for essential covariates such as substance use history, age, and gender. And this is particularly relevant in the treatment-related outcomes literature. And finally, for the majority of the literature, neurocognitive domains were assessed in isolation. In order to appropriately evaluate the neurocognitive mechanisms of addiction, requires an investigation of multiple neurocognitive domains in the same model. This will then allow us to determine, when held accountable to each other, which are the best predictors of addiction or addictive behaviours and addiction outcomes. So it's evident that we need a lot more research in this space. And I've got some key recommendations for those who would like to contribute to this field. Firstly, as previously mentioned, we need to assess multiple neurocognitive domains in the same model. Secondly, it's essential to appropriately account for key covariates in analyses. I know I sound like a broken record, but it's so important, especially history of addictive behaviour. And finally, I recommend not just looking at how neurocognition at baseline predicts future behaviour, but also assessing neurocognition over time and use analyses or analysis techniques that are able to capture the potential change in neurocognition and look at it in relation to change in addictive behaviour. So techniques like structural equation modelling or latent growth curve modelling approaches. So this is particularly relevant for cohort studies with samples that span across adolescence to adulthood. I want to say a big thank you to my supervisors, Murat, Lucy, and Rico, and also to Maya, who was a big contributor to this review. On to you, Lara.
Thank you, Erin. So today I'll be presenting on my PhD project, which is on understanding the motivational mechanisms of alcohol use disorder. So alcohol-related harm contributes to 3 million deaths annually worldwide. Alcohol use disorder, or AUD, is one of the most prevalent mental disorders globally, with lifetime prevalence rates estimated at 8.6% worldwide and 22.7% in Australia. AUD is defined as a chronically relapsing disorder characterised by repetitive and compulsive alcohol use, despite adverse consequences to the individual and society. These adverse consequences include increased risk of cancers, cardiovascular disease, dementia, and other cognitive impairment, motor vehicle accidents, suicide, crime, and violence, such that this alcohol-related harm costs Australia an estimated $36 billion each year. Now, despite AUD's extreme prevalence and adverse consequences, current treatment for AUD is insufficient, as it's characterised by low compliance and substantial relapse rates, such that up to 90% of individuals with AUD relapse within the first year after treatment. Perhaps one reason for this is that individuals with AUD may not be receiving the most effective or appropriate treatment for their specific clinical presentation. The DSM-5 defines AUD along a single spectrum of severity, ranging from mild to moderate to severe, depending on the number of criteria met out of 11. So in order to be diagnosed with AUD, you only need to meet 2 out of these 11 criteria. This results in 2,048 potential symptom combinations, making AUD a highly heterogeneous disorder. And this large heterogeneity has led researchers to investigate phenotypes of AUD. One such way that you can phenotype individuals with AUD is based on their drinking motives. So that's their underlying reason or motivation for consuming alcohol. And we've termed these the motivational phenotypes of AUD. So recent research from our lab has identified 3 main motivational phenotypes of AUD. The existing literature has identified similar groups, but they may have used different names. Importantly, though, these groups are not mutually exclusive, and the same individual may differ in terms of their drinking motives, depending on the point in time. So the first group are those that predominantly engage in reward-driven drinking, meaning that they predominantly consume alcohol for its rewarding effects, such as because they like the taste of it. Alternatively, another group that we have identified predominantly drink to cope with stress, distress, and other negative emotions, also called relief-driven drinking. And a third group are those that predominantly drink sort of automatically out of routine, also referred to as habit-driven drinking. So again, this is just one way of grouping these individuals, and others may have grouped them using different names such as relief-seeking or distress-driven. Research, though, has shown that these groups do differ in terms of their psychopathology as well as their treatment responses. So, for example, those that predominantly engage in relief-driven drinking and habit-driven drinking show greater stress and anxiety symptomatology, greater alcohol-related problems, including higher levels of dependence, severity, and craving, and they're also at an increased risk of relapse compared to those that predominantly engage in reward-driven drinking. Conversely, those that engage in reward-driven drinking benefit the most from a medication known as naltrexone, which works to reduce alcohol by reducing the rewarding effects of alcohol, whereas those that predominantly engage in relief-driven drinking benefit the most from a medication known as acamprosate, which works to reduce alcohol use by reducing the withdrawal symptoms of alcohol. So given that we know that these motivational phenotypes differ in terms of their psychopathology as well as their treatment responses, it's important to continue to look at other mechanisms that are underlying these phenotypes so that we can personalise interventions to address specific areas of dysfunction. And we're particularly interested in the cognitive affective mechanisms as these play a large role in the maintenance of AUD. So according to the incentive sensitization theory of addiction, repeated alcohol consumption causes neuroadaptations within the brain's reward circuitry, resulting in it becoming sensitized. Through Pavlovian classical conditioning, previously neutral cues and contexts, such as a beer bottle or a bar, gain incentive salience, meaning that they become implicitly wanted or craved through repeated association with alcohol's rewarding effects. So over time, these alcohol-related cues become capable of eliciting a subjective, conscious desire to consume alcohol, which is referred to as cue-induced alcohol craving in the literature. Importantly, though, stress is also capable of eliciting alcohol craving, which the literature refers to as stress-induced alcohol craving. And indeed, previous research has shown that greater stress-induced alcohol craving predicts a shorter time to alcohol lapse, increased alcohol consumption, and fewer days spent abstinent. So neurocognitive dysfunction also plays an important role in the maintenance of AUD. I won't go into too much detail with this as Erin has already sort of discussed this, but essentially these neurocognitive constructs, or some of them have been found to predict the progression from heavy drinking to dependence and to predict alcohol relapse. Importantly, our traditional neuropsych tests aren't the best at measuring these constructs. So our lab has developed the BrainPack app to measure these constructs, which the current project will be using, and I'll get into that in a little bit. Many studies have assessed neurocognition in addictive disorder populations, especially AUD. However, few have investigated the efficacy of providing feedback to participants on their neuropsych assessment results, which is termed neuropsychological feedback. So neuropsych feedback is a common part of the neuropsych assessment process for many other neuropsychological disorders like epilepsy, MS, stroke, dementias, and so on. Not only does it involve a discussion of the assessment results, but clinicians also provide compensatory strategies to clients to help them manage their cognitive difficulties in their everyday lives. So previous research has shown that personalised neuropsych feedback has had a positive effect on patient outcomes in these populations, such as better quality of life, reduced psychiatric and cognitive symptoms, and improved self-efficacy. But the research evaluating the benefits of neuropsych feedback in general is limited, so even in those populations. And to our knowledge, it's pretty much non-existent for addictive disorder populations. Even if research has investigated its efficacy in addiction populations, the neuropsych tests that are used are old and they're not really that suitable for capturing the cognitive impairments that are specific to addictive populations. So that brings me to the current project, which is known as the Alcohol Cue Exposure and Virtual Reality, or the ACE-VR project. The previous research investigating the mechanisms underlying the motivational phenotypes of AUD have focused on assessing the neural and the clinical correlates. So the overall aim of this project is to use novel technologies to understand the cognitive affective mechanisms underlying the motivational phenotypes of AUD, which has not been done thus far. So specifically, we'll be looking at stress-induced alcohol craving and neurocognition. Most previous research using cue reactivity paradigms to assess craving have used a standard set of alcohol cues for every participant, such as a set of 10 images of different alcoholic beverages. But the problem with this is that if the majority of images are of spirits like vodka and whiskey, but a participant mainly drinks wine, then their craving is likely to be underestimated. So in the current project, we're adopting a more ecologically valid approach to measuring craving by using a VR cue reactivity paradigm, which allows for immersive experiences, such as exposing participants to the sights and sounds associated with alcohol use and allowing them to interact with these alcohol cues in different drinking environments. Additionally, most previous research assessing neurocognition in addictive disorders has used traditional neuropsych tests, which, as I mentioned before, sort of lack that sensitivity for measuring neurocognitive dysfunction in AUD, as they predominantly focus on traditional cognitive domains, which are less relevant to addiction. So in other words, those tests are not really purpose-built to assess those 7 neurocognitive constructs. So this project will use a purpose-built assessment tool, the BrainPack app, to measure neurocognition across the AUD phenotypes. And as I mentioned earlier, to our knowledge, there really hasn't been any previous research investigating the efficacy of personalised neuropsych feedback in reducing alcohol use in AUD. So this project will be the first to do so. So that brings me to our hypotheses. So we hypothesize that the motivational phenotypes will show different patterns of neurocognition under stress versus no stress. For example, those that predominantly engage in relief-driven drinking may exhibit poorer response inhibition under stress compared to those that predominantly engage in habit or reward-driven drinking. We hypothesize that stress-induced alcohol craving will differ across the motivational phenotypes, such that those that predominantly engage in relief-driven drinking will exhibit the greatest stress-induced alcohol craving compared to those that engage in habit and reward-driven drinking. That greater neurocognitive dysfunction and or stress-induced alcohol craving will mediate the relationship between motivational phenotype of AUD and alcohol use at a 2-week follow-up. And lastly, that individuals who receive personalised neuropsych feedback, which includes an explanation of their drinking and their neurocognitive test results, as well as compensatory strategies, will show greater reductions in alcohol use at a 1-month follow-up compared to individuals who receive personalised feedback on just their drinking. So we're aiming to recruit 60 individuals aged 18 to 55 years old with moderate to severe AUD. And we've recently initiated a collaboration with Cicada, which is the AOD consortium for the southeast suburbs of Melbourne. So Cicada governs sort of several AOD agencies, and we'll be recruiting from there, like Windana and Odyssey House. So in terms of the procedure, interested individuals with AUD will be referred to a brain park researcher by their AOD clinician that they've been having sort of regular sessions and established a therapeutic alliance with. Those that are interested will then be contacted by a researcher who will conduct a brief telephone screening to assess their eligibility. Those that are eligible will then come in for 2 1-hour in-person sessions, which involve a social challenge, the virtual reality task, and some cognitive tasks. So only one of these sessions will involve the social challenge, and the order of this will be counterbalanced such that half the participants will be randomly allocated to receiving or undergoing the social challenge in the first session, and the other half will receive it in the second session. Then 2 weeks after the second in-person session, the participants will receive personalised feedback. And then 2 weeks after receiving that personalised feedback, they'll undergo sort of a brief telephone interview to assess their alcohol use. So in terms of how stress will be induced, we are using the simple singing stress procedure, which has been validated to induce both subjective and physiological stress responses, including increased blood pressure and saliva cortisol levels. I won't be going into too much detail with the procedure, but if you are interested in the protocol, the reference is here. Essentially, though, it involves an initial singing phase where participants have 60 seconds to sing in front of a researcher, and their audio and video recorded, and then they'll be told that they have to sing again at a later phase, so singing phase 2, by a panel of researchers. So it adds that sort of social evaluative threat, which is important for reflecting actual psychosocial stress that people experience in their everyday lives. And also that anticipation of having to sing again is likely to maintain stress at a high level. So in the periods between singing phase 1 and singing phase 2, that's when we'll be administering the cognitive tasks and the VRQ reactivity task to assess stress-induced alcohol craving and neurocognition under stress. In terms of how we'll be measuring stress, so subjective stress responses will be measured using a visual analog scale, and objective stress responses will be measured using a sport watch to measure heart rate and collecting saliva samples to measure cortisol levels. So we're also collaborating with the University of Barcelona, who have designed and validated a VRQ reactivity paradigm to assess alcohol craving in AUD. So this software was created to include the alcohol cues that elicit the highest levels of alcohol cravings in AUD. So that consists of 22 different alcoholic beverages and 4 different drinking environments, which you can see here. So a bar, a restaurant, a pub, and an at-home drinking environment. The VR software also has 2 built-in visual analog scales in which participants rate their cravings for each of the different alcoholic beverages and the different drinking environments on a scale from 0 to 100, where higher ratings indicate higher craving levels. So participants rate their cravings before entering the VR software, so the different drinking environments, so that it sort of calibrates it to show them only the 5 highest rated beverages. So in that way, it's tailored to the individual's specific preferences rather than just using that standard set of alcoholic beverages for every participant. All right, so obviously in that video, it was still in Spanish, but we have translated it into English to be able to use it for an Australian population. And we've also changed some of the beverages as well to Australian beverages. All right, so I'll just finish off with some clinical implications of this research. So firstly, by using novel technologies like VR and gamified cognitive tasks, we can better understand some of the mechanisms that may contribute to an increased risk of relapse in AUD across the motivational phenotypes. So this is important as our findings may be able to inform the personalisation of interventions for individuals with AUD, rather than relying on a one-size-fits-all approach to treatment. So, for example, if we discover that individuals who predominantly engage in relief-driven drinking have the highest levels of stress-induced alcohol cravings, then perhaps they may benefit from including a specific intervention to target those particular cravings, like incorporating a mindfulness-based stress reduction intervention into their treatment plan. This personalised treatment approach may then lead to sort of lower relapse rates by helping individuals reduce their drinking and maintain abstinence. So lastly, I'd just like to thank my PhD supervisors, Rico, Lucy and Murat, as well as the rest of the Brain Park team for their support and guidance throughout my PhD so far, as well as the Cicada team and the virtual reality lab over at the University of Barcelona for collaborating with us on this project.
Brilliant. Thank you so much, Erin and Lara, for two wonderful presentations. If anyone in the virtual audience would like to ask either or both of the presenters a question, please do put it in the Q&A. I might start with some questions for Erin. So, Erin, of the 34 studies in your review, the participant groups were quite variable along some key demographics, age, gender, sometimes only males were included. Can you comment a little bit on how this affects the results and particularly generalizability?
Yeah, sure. So I did pop in the slides where it was of note that things were different, like it was all male samples and things like that. But most of the studies did cluster in groups of cohort studies looking at adolescence to early adulthood, early college samples. In terms of the, I guess, consumption or problematic use outcomes literature, there was very little looking at problematic users. There was really only that one study that I identified, which was Rubio and colleagues looking at the heavy users. So it does impact generalizability in that we can only really speak to it in terms of most often alcohol consumption, and really in those adolescent to young adult samples. There's a lot missing in the space between like the ages of 21 and then 35. So I think it does show that it's difficult to generalize some of this work, or a lot of this work.
Right. And I guess picking up on one of the things that you raised there, looking at the slides you presented on the positive valence studies with delay discounting and the audit scores, the sample was really young. And the audit, of course, has, dependence and problem use items. Are they likely to be seen in a group so young?
In the studies that I showed, all of them showed a change from baseline to follow-up. So there was a change and an increase in audit criteria. So you're right, it's something that we go into a little bit more detail in the actual review around whether these measures are even relevant or sensitive in these cohorts. But the ones that I presented today, it was relevant in that there was an increase in audit scores, and that was a significant increase for the studies that I presented.
Thanks, Erin. I might switch to asking Lara some questions now. So Lara, thank you very much for your presentation and hearing about, some of the wonderful work that you're doing. I want to take you back to some of the background of your work around the motivational phenotypes. And the classifications were very much based on individual behaviours, so reward, relief, or habit. But do social elements like social connection and drinking with others affect these motivations?
Yeah, I think that it definitely would, especially with, all of them, reward, particularly especially if you're, drinking to celebrate something, drinking because you like the taste of it, that could definitely influence that particular phenotype, as well as relief-driven drinking as well. So particularly if you are drinking in a stressful social environment, then that could drive someone to drink to cope with that sort of social, that particular social stressor.
Right. And is there a way in your collecting of immersive, I guess, cues and information from participants that you could control or include that in some way in the VR elements?
Yeah, I guess I haven't really got a specific thing that I have included, or a specific measure that I've included in my study to control or adjust for that. But that is a good point. Yeah.
And I guess following on from that, I mean, I think it's fantastic that you're collecting this immersive, tailored information. How do you actually collect that information from participants, and how much does it vary? Like, does it go to the level of preferred brands of particular drinks or bars or locations?
Yeah, so we just have the one bar. So in terms of the different drinking environments, it's the set environments that I showed you. So those 4 different environments. And in terms of the drinks, it's different alcoholic beverages and different brands, the ones that we think are the most popular in Australia. So that's what we sort of worked to do when we were translating it from Spanish into English, as obviously the researchers over at the University of Barcelona found the alcoholic beverages that were most craved in a Spanish population. But for us, we wanted to change the beverages, as that they don't really apply to Australian populations in terms of what we drink over here. Yeah, so there's specific brands.
Thanks, Lara. I might switch back to asking Erin some questions, and I'm going to try and link this so we can make it a very much open discourse. Erin, a question I asked Lara was about sociocultural elements, and I wonder whether you could comment on where the studies that you identified in the review were conducted, whether they're in the same country or different ones, and whether any sociocultural elements such as attitudes to alcohol or drug use or gambling were examined.
You make an excellent point. And in the many iterations of trying to tease apart and find links in the literature, one of them was I applied where are you from? Are there different sociocultural relationships, particularly with alcohol? A binge drinking cohort of Australians could be quite different to drinkers over in Europe. So I did apply that lens, and it was really difficult to find really clear links that easily explained, it's because of this cohort. It was in a Spanish cohort. That's why it was different results. So I can't comment in terms of that being a good explainer. But in terms of the samples that we looked at, most of the treatment-related work was in Spanish cohorts, particularly looking at cocaine. We had some large-scale studies that were run across Europe, in places like Germany and the Netherlands. And then there were a few studies, mostly in college students in the US. So it actually wasn't particularly varied. There were, I guess, those 3 key cultural domains that people did literature in this space. So it would be a very interesting thing to look at, particularly in the binge drinking space.
Sure. And I guess, Erin, given the lack of studies here in a very ultra 1-minute elevator pitch answer, what can we learn from the animal studies that have been conducted in this space? And is there differences or commonalities across different species?
Unfortunately, I haven't spent a lot of time in my PhD focusing on the animal literature. So my knowledge is pretty broad strokes. So it's probably not the best question for me. I'm so sorry.
Put that one on notice.
Yeah. But to hijack this question that you've asked me, I can't believe the lack of literature in human studies longitudinally. I had to go through this several times with multiple people to say, have I missed something? Because it makes no sense given, all of the work that we've supposedly done has led to a PhD based on these neurocognitive predictors. And there's not really much there. So I think that there is a substantial amount of work in the animal literature space, which is why we've got a lot of these assumptions. But it is important to then bring it out to human studies and see whether neurocognition really is as relevant as we want it to be.
Thanks, Erin. I'm going to switch back to Lara. And we've had a question come through asking if you could say exactly which brands or beverages you're using in your simulations.
Yeah, I definitely couldn't list all of them. There's 22. But if you are interested after this, I can share them all with you. I can list a few now. So I think Jack Daniels, Smirnoff, basically the most popular brands that are also relatively cheap in each of the different types of alcoholic beverages, so spirits, wines, ciders, and so forth. So making sure we have a mix of different types of alcoholic beverages and then picking sort of the most popular brands from there. So, yeah, I can definitely share them after this. Yeah.
Thanks, Lara. And another question around whether motivation to drink changes across addiction severity, say from recreational use to more problematic use. Can you comment on that?
Yeah, so, and I did mention a little bit about that in the intro, that relief-driven and habit-driven drinking tends to be associated with a greater alcohol severity compared to reward-driven drinking, and that sort of follows that positive versus negative reinforcement, how you start off drinking because you like the taste of it, and then that sort of progresses to drinking to remove the withdrawal effects and so forth, that typical addiction cycle. Yeah.
And are there gender differences as well that you or others have explored?
I'm not too sure about the gender differences. Yeah, I'm sorry. I'm not too sure about that.
And a final question for you, Lara. How transferable, similar or different are these motivations to other addictions or addictive behaviours?
Yeah, I mean, a lot of my research has focused on alcohol use disorder specifically, but I think that they would be transferable to other addictions. Using it because you like the rewarding effects of it, or versus to cope with something. I think that would be transferable to other addictions. Yeah. Especially, thanks. I think there's quite a lot, especially with behavioural addictions. So I know that this research has also been used in, these motivations have also been looked at in terms of food addiction as well. Yeah.
Thanks, Lara. And on that note, we've reached the top of the hour, so the end of today's talking point. I want to thank you so much, both Erin and Lara, for presenting today. Really interesting talks. Thank you to everyone who's joined in the Zoom. And if you subscribe to the Turning Point website, you'll be notified of when the recording of this event is available to view. So thank you very much for attending, and please enjoy the rest of your afternoon.